So I'll be talking a little bit about some preliminary results of a study that we collected maybe about a year ago, and I'm excited to share some of this with you. So I'll get right into it. Approximately 12% of nighttime and morning falls in older adults are often followed by a transition to standing. And what some of you may know is that when we transition to standing, let's say from lying down, we get a transient drop in both blood pressure and brain blood flow, which you can see here in the blue and gray tracing, and it does recover. So as you can see, this individual is lying down, and then as they stand up at time point 0, we get this transient drop. It reaches its lowest point, or its nadir value, at approximately 7 to 9 seconds after they stand up, and this typically recovers within 30 seconds. However, in 21% of the older adult population, it's been reported that this blood pressure does not recover by 30 seconds. Furthermore, although cerebral autoregulation is considered intact in older adults, the age-related declines in brain blood flow may be placing some older adults at risk of cerebral hypoperfusion when they get up from sitting or lying down. Which brings me to the first objective of this study, which is to examine posture-related reductions in cerebral tissue oxygenation during a transition to walking. So we had 21 older adults, average age 87, perform a lying to walking transition. And while they did this lying to walking transition, where they walked for 1 minute, they wore a piece of equipment on their forehead called near-infrared spectroscopy, and it measured a sample of oxygenation within the brain tissue. I would also like to talk to you a little bit about arterial function. Now, arterial stiffness, which often happens with age, reduces the cushioning effect of the arterial waveform, and this increases the pulsatility that's being exposed to the cerebral vasculature. So what you can see on the bottom here is vascular compliance. So we see on the left there is an elastic artery, and on the right there's a stiff artery. So what's happening is, as the heart contracts and shoots out a bulbus of blood, the elastic artery can cushion that bulbus of blood, whereas the stiff artery, it doesn't cushion it as much because it's much stiffer, and as a result, we get a change in the pressure waveform, which you can see on the top. So in the top two graphs, we have a pressure waveform. So this is the pressure within the artery for one contraction of the heart. And you can see there's an individual with low pulse pressure and an individual with high pulse pressure. So the individual with high pulse pressure ends up having a lot of pulsatile stress being exposed to their cerebral microvasculature. Now, it's been reported that stiffer arteries are highly correlated to both lower brain blood flow and increased cerebrovascular resistance. It's also been shown that stiffer arteries are significantly related to, or are significantly stiffer in older adults who have had a fall compared to those who have not had a fall. And for this reason, it brings me to my objective 2, which was to examine the relationship between posture-related reductions in cerebral oxygenation and indices of vascular stiffness, particularly carotid pulse pressure and carotid compliance coefficient. So after all of the participants performed a lying to walking transition, we had them lie down for about 15 minutes, and we collected information of carotid pulse pressure and carotid compliance coefficient. So we placed an ultrasound probe on one carotid artery and a tonometer on the other side, and we collected both the compliance of the artery and the pulse pressure. From the change in brain oxygenation from lying to standing, this delta drop in brain oxygenation, we use that alongside carotid pulse pressure indices to separate our participants into 2 different groups. And those 2 groups we've labeled as having good and poor cerebrovascular regulation. And I'll be using these 2 groups throughout the rest of the presentation. So here are some of the results. This is a tracing of cerebral oxygenation when going from a lying to walking transition. And you can see there's an individual with good and an individual with poor cerebrovascular regulation. And there are clear differences between the 2. And for this reason, we then looked at 3 different time points to compare these 2 groups. We took an average from baseline, We also took the nadir value, which was again that lowest single point upon standing. And we also took an average during walking for these two groups. And here are the results. So I did a mixed model repeated measures ANOVA, and what you can see is there's a significant interaction by group and time point. So if we look at the black bars, you can see across all 3 time points that the black bar does not change very much. At the nadir, once they're upright, it does lower, but however, once they're walking, it increases again. And if we compare this to the gray bars, so we have the individuals with poor cerebrovascular regulation, not only are the gray bars lower at all time points, but their drop at nadir is their drop relative to baseline at nadir is much greater, and when they're walking, that value does not return to the same level at baseline as we see in the good group, or the individuals with good cerebrovascular regulation. So from this, what we've concluded is that individuals with low brain oxygenation will have lower brain oxygenation at supine rest, while they're transitioning, and as well during walking. So here's, I'm going to talk a little bit about the carotid pulse pressure and compliance measures right now. And what you can see here are 2 individuals, and this is their carotid pulse pressure. And it's obvious here that they have very different pulse pressures. So the individuals who are in the good cerebrovascular regulation group, so those with with high brain oxygenation, also have a much lower pulse pressure compared to the individual with poor cerebrovascular regulation. And if we look at the group differences, what we can see here is that when we're looking at that carotid pulse pressure, the first set of bars, the individuals with poor cerebrovascular regulation have much higher pulse pressure, exposing the microvasculature to those that pulsatile stress, and that's for every beat of the heart. And we can also see that the individuals with good cerebrovascular regulation have much more compliant or much more elastic arteries compared to the individuals with poor cerebrovascular regulation. So what we can take from this slide is that the individuals with good cerebrovascular regulation have lower pulsatility as well as more elastic vessels. So in conclusion, the individuals, what we've seen are that significant differences in cerebral oxygenation exist among older adults when at rest, during a transition, and while walking, and this may be placing some individuals at risk of cerebral hypoperfusion and also placing them at an increased risk for a potential future fall. Older adults with low cerebral oxygenation also have stiffer vessels, and this is suggesting that there is a relationship between changes in arterial function and cerebrovascular hemodynamics. And so future research can further explore the relationships between altered vascular function and low cerebral oxygenation. And that's it. Thank you.
Thank you, Laura. Any questions for Laura?
Okay, great. Oh.
Have you tried to document
flow volume going up to the brain?
So we do have measures of flow at supine rest and at seated rest. But again, these were just preliminary results, and so most of it's been analyzed, and it's certainly something that we're looking at. Mm-hmm.
And I'm guessing that this is work from your thesis project, and so what are some of the next research questions that you have based on your findings?
Well, this is the last study.
Oh, okay.
But next steps would be which is something I think Rich is looking at in the future, would be to not only look at the healthy population, but to look at chronic diseases and how do those differ from the healthy population that I've collected.
Great. Yeah, that seems like a natural next step. Great. Well, thank you.